Hello everybody, it's Peter with an I, S-T-A-W-A-R-T. In a previous episode we talked about vacuum forming polystyrene for the outer shell of the electronic saxophone. In this episode I'll talk about the keys. For the electronic saxophones I make, I use keys from Cherry brand computer keyboards. The reason I say Cherry brand is because not all computer keyboards are the same. If you take apart the first keyboard that you come across, it's extremely likely that you'll find a rubber mat covered with little bumps. The individual keys are just plastic shells. You want the complete switch. I'll just let you know, if you want, you could use buttons made for electronics platforming. It would be cheaper and easier to go that route. There are some advantages to using Cherry keys. You can feel the difference when you press them. Also, the look of the project screams computer nerd. I make these electronic saxophones to double as lamps, and you know right away that these keys were repurposed from an entirely different electronic device. It embodies the pioneer spirit of hacking. Throughout this project, it's a great idea to test the keys. There's a number of things that we'll be doing that can screw them up, and it's a shame to get too far into the project with keys that don't work. I say give a test run and make sure they work and in the way that you want them to work. Not all switches are the same. I oftentimes get bags of electronic parts and I'm not sure exactly what I have. What you want is a button that is open when you leave it alone, and it closes the circuit when you push it and opens it when you remove your finger. What you don't want is something that clicks once to close the circuit and you have to actively click it again to open it. Next, choose the wire colors for each button and make a map. This map has the color of each wire along with a number. I repurpose old Cat 5 cable. I pull out all the solid green wires and put them aside. In all my projects, I try my hardest to only use green for ground and red for V or voltage. Some of these projects involve so many wires, it helps to keep track of things. Now, cut them at nice lengths. I use Cat 5 cable, but you can use what you want. If it's stranded, that means you pull off the plastic sheath and there's a bunch of little wires. It makes it really easy to wind them around the little feet. If it's solid wire, it's all too easy to find stranded wire and wrap it around. Whatever the case, your wire should cross over and the two wires should crisscross. Now, this is optional. Take a little super glue and anchor the wires together and to the bottom of the key. For the next part, I'll tell you the best way of doing something, the subpar way of doing something, and the worst way of doing something, which happens to be my way of doing something. The best thing that you can do is coat the junction with conductive paint, a silver epoxy. The problem with that is that you just need a small amount for this project, and it doesn't come in tinctures, small amounts. You have to open an expensive jar, and once open, it'll dry out. Wasteful! And I don't want this project to be cost prohibitive. You need to put something on it because we'll eventually be using foaming glue. If you put foaming glue on a cluster of packed wires, you run the risk of foam expanding and pulling the wires apart. The subpar method of protecting the cluster of wires is to take a very small strip of tinfoil and pinching it flush, and you wrap a little wire around it. Now, I'll tell you the worst way, which is the way that I do it. You can't solder the joint because the heat will melt the surrounding plastic and ruin the switch. So, I'm going to solder it. See, I told you it was the worst way of doing it. You've heard before that you can't believe everything you hear on the internet. Well, this may be one of those times. I'll tell you something which may or may not be true. I put a drop of water at the base of the metal foot where the metal meets the plastic. When the wire gets hot, the water boils off and, I presume, carries heat away faster than normal air cooling. When the water boils away, I replace it with another bead of water. The boiling of the water seems to save the plastic and the switch, but I'm not sure it does. It may just be my imagination. As it stands, we have something that looks like this. Use tin snips to cut a soup can. Use pliers to shape it. The sides roughly conform to the polystyrene shell. Leave about a thumb width here. Mark it, tape it, make marks kind of where the fingers go. I'm going to use a little letter A with an underline here. Underline a little B here. See, it's hard to know which one is which and which direction these go. Remember the coloring strategy? The different keys will eventually be around here. We'll mark where the wires will go through to the other side with X's and make nail holes. We'll make additional nail holes along these lines. Press in polymer clay from the craft store. This is oven-baked clay. Work it in through these holes. These holes will help anchor it to the metal. These are all in a line to avoid confusing them with the wire holes, which we will keep open by using a nail. If you bump the clay before it goes into the oven and the hole is closed, don't worry. You can auger it out with a rotary tool. Press the corresponding key with the wires into the clay. Work it in there. The intention is to create a form-fitting plastic seat the wires will snake through to the other side. The goal is to have the buttons peeking out through the holes in the polystyrene. It may take some adjustments. It will take some adjustments. You may have to bend the metal of the soup can. I cannot emphasize enough how unimportant it is to have the metal of the soup can form fit to the contours of the polystyrene shell. It's hard enough getting the buttons exactly where you need them to be. Tinkering with the metal to make it fit perfectly should not be your focus. Make adjustments to the metal soup can, make adjustments to the keys that are mashed into the clay, and perhaps shave off some of the polystyrene. We'll eventually use foam and glue to hold the keys in, to help that foam and glue stay where it needs to be, and for it to help it do its job, we'll make a tiny little wall. These keys will need to come off before this goes into the oven, so avoid trapping them with the clay. Also, the tiny wall mustn't interfere with the button head. Another thing you want to do at some point before it goes into the oven is to press little numbers in where the wire holes are on each side, and make notes on your map. Gently pull the keys free and put the polymer clay in the oven. Don't put the switches in the oven, just the clay and the metal. Follow the baking instructions on the box, pull it out and let it cool. The numbers you pressed in the clay will help you figure out which switches go where. Keep in mind, this is a simplified project where we're only doing 7 keys, and it gets complicated enough. If you want to do more keys, these markings become increasingly essential. Whenever you use foam and glue near these keys, you'll want to protect them. Even the smallest amount of glue gets into the key and it's ruined. Use masking tape and make a little pointy hat. It'll protect the key, and the points will help you make sure that the button will be at the correct angle. Get the first one ready to go, wet the surface, dab on foam and glue, tape it in place and move on to the next. Foam and glue may cover your wires in places, making it tough to tell what color they are, but the numbers you scratched into the clay will help remind us. For this application, it's better to use too little foam and glue as opposed to too much. Once it's dry, test the buttons, make sure they still work. Don't assume that they will. Shave off what you need with a rotary tool and paint this part black.